Okay, so we have a polar equation here. We know that it's got an r and theta, and we want to write it as a Cartesian equation. Okay, so first I'm going to multiply the denominator out. So I'm going to have r times 1 minus 2 cosine theta equals 3. So I'm kind of like getting rid of that denominator. Okay, so then I can replace cosine theta. Now remember, x is equal to r cosine theta. So cosine theta is equal to x over r. And we've seen that before as well. Might not remember it, but we've seen it. Well, that gets rid of the theta then. And so if I distribute r, I get r minus x equals 3. Oh, I got a 2 in there, sorry. You're like, where'd that 2 go? There it is. Okay, so when we distribute here, we get r times 1, and then when we distribute here, the r's are going to cancel, and that gives us 2x equals 3. So we have an r, but we don't have the theta anymore. Okay, that's what I meant to say. Okay, the r, though, is a little bit of a problem. Now, you might be saying, well, we know some things about r. We know r squared is equal to x squared plus y squared. That's true. We don't have an r squared, but we could create that. So what we're going to do is we're going to put the 2x on the other side. I would probably write it like this. And then we're going to square both sides. And now you can use this. So we'll put the x squared plus y squared equals 2x plus 3 squared. Now there's all kinds of things you could do with that equation. First of all, this is okay because it's in rectangular coordinates, right? It doesn't have an r or a theta, so that's good. You could multiply out the right and then get it in the standard form for, this is going to be a hyperbola. But we didn't really cover hyperbolas in this class, so I'm not going to show you that process, but you could do that if you knew how to do that. Or if you were like, no, I want to put this, I want to see a graph, I want to put it in my graphing calculator or Desmos. If you were going to do something like that, then you could solve for y. And that would look like y squared equals 2x plus 3 squared. I probably wouldn't multiply it out. Minus x squared. And then you could have y equals plus or minus the square root of 2x plus 3 squared minus x squared. And that you could plug into a graphing calculator and it would be just fine. Yeah, so the form's not great, but again, we solved for y. So that has some advantages to it. The big thing is we got rid of the r and we got rid of the theta, so it's in rectangular coordinates.